Hi everyone, myself Dr. P. Ashok Babu, working as Professor and Head, IC Department. In this video, I am going to discuss about some more problems on wave propagation. Identify frequency, phase constant when the electric field of an EM wave is given by E is equal to 5 sine 10 power t minus 4.4x into Az. Then we have to find out the wavelength also. So here the given electric field intensity E is equal to, here it is 5 sine 10 power 8 t minus 4x into Az. So which is of the form of E is equal to, it is A sine omega t minus beta x into Az. Beta x into Az. Then for this we need to find out the frequency, phase constant. Then we need to find out the wavelength lambda. So here if you compare the same expression, then the amplitude A is equal to 5 and the angular frequency omega equal to 10 power 8. Therefore, from this you can find out the frequency 2 pi f equal to 10 power 8. Therefore, f equal to 10 power 8 by 2 pi. So, which is 15.915 megahertz. Then we can, if you compare the same, then here we have beta is equal to 4 radians per meter. So, if you compare the beta is equal to, from this we have beta equal to 4. Beta equal to 4. Then the wavelength lambda equal to V naught by f, where V naught is 3 into 10 power 8 by frequency f is 15.915 megahertz. Therefore, it is 18.850 meters. Next problem. So, find the depth of penetration delta of an EM wave in copper at a frequency f equal to 60 Hz and frequency f equal to 100 megahertz. We need to find out the depth of penetration at two different frequencies, at f equal to 60 Hz and at f equal to 100 megahertz. For a copper, where sigma is given as sigma equal to 5.8 into 10 power 7. 5.8 into 10 power 7 moles per meter, mu r equal to 1 and epsilon r equal to 1 is given. So here, before finding the depth of penetration, so here we will find the dissipation factor. So here the dissipation factor is nothing but sigma by omega epsilon. If sigma by omega epsilon is known as the dissipation factor. If the dissipation factor sigma by omega epsilon is very greater than 1, if sigma by omega epsilon is very greater than 1, then we can call the material as a conductor. We can call the material as a conductor. If sigma by omega epsilon is very less than 1, then we can call the material as a dielectric material. We can call the material as a dielectric material. So based upon the dissipation factor, we can differentiate whether the given material is a conduction material or conductor, or the given material is a dielectric material. So here we will find the sigma by omega epsilon. Sigma is nothing but sigma is given as 5.8 into 10 power 7 by omega is nothing but 2 pi f. 2 pi into f is given as 60 Hz. Then omega epsilon is given. Epsilon equal to, we have epsilon naught into epsilon r. Epsilon r equal to 1. Therefore, we can substitute epsilon equal to epsilon r. Epsilon naught is 8.854 into 10 power minus 12. So here, if you simplify the expression, we have 174 into 10 power 14, which is very greater than 1. Therefore, the given material is a good conductor. Copper is a very good conductor. Then we can find the depth of penetration. We have the depth of penetration formula. Delta is equal to 1 by alpha, where alpha is nothing but the attenuation constant. So which is how the formula is equal to root of 2 by mu omega mu sigma. Actually, we have alpha is equal to, we have the formula alpha is equal to, have the formula root of omega mu sigma by 2. So because it is 1 by alpha, it is root of 2 by omega mu into sigma, where omega is nothing but again 2 pi f, 2 by 2 pi f. Mu is nothing but mu is equal to, we have mu naught into mu r equal to 1. Therefore, we can substitute mu is equal to mu naught. Therefore, mu naught is 4 pi into 10 power minus 7 and sigma is given, conductivity is given 5.8 into 10 power 7. 10 power 7 cancel each other. Therefore, 4 pi into 8 pi. Therefore, after simplifying all this, we have depth of penetration. Delta is equal to 8.53 into 10 power minus 3 meters. Similarly, we need to find the depth of penetration at a frequency of 100 megahertz. So, at 100 megahertz, find out the dissipation factor. The dissipation factor is again very greater than 1. then copper is a very good conductor at high frequency, that is F equal to 100 megahertz. Then the depth of penetration delta is equal to 1 by alpha, which is equal to root of 2 by omega mu sigma. So, if you substitute all the values, it is 2 pi f, where f is 100 into 10 power 6, and mu is nothing but mu naught equal to 4 pi into 10 power minus 7, and sigma is 5.8 into 10 power 7. So if you simplify the expression, it is 6.608 into 10 power minus 6 meters. 10 power minus 6 meters. So at low frequency, we have 8.53 into 10 power minus 3 meters. At high frequency, we have 6.608 into 10 power minus 6 meters. So as the frequency increases, the depth of penetration decreases. We need to observe that at high frequencies, the depth of penetration is low. Next one. Next problem. The electric field of a plane wave propagating in a medium is given by E is equal to, we have 4 into e power minus alpha x into cos of 10 power 9 into pi t minus beta x into az is given. So here the medium is characterized by sigma r equal to epsilon r equal to 49, mu r equal to 4, and sigma equal to 4 mole per meter. So find the magnetic field of the wave. So here we need to find out the magnetic field of the wave. Then we need to compare the expression. So here E is equal to 4 is the amplitude, e power minus 4 e power minus alpha x is the attenuation constant. Therefore E is equal to, we have amplitude A into some attenuation constant into cos of omega t minus beta x, cos of omega t minus beta x, where omega is nothing but, if you compare the expression, omega is nothing but 10 power 9 pi, 10 power 9 pi. So here if you find the dissipation factor, it is sigma by omega epsilon, sigma by omega epsilon, it is sigma is nothing but 4 is given, 4 by omega epsilon, omega is nothing but 2 pi f, it is 2 pi into f is, omega is nothing, omega is directly, we can substitute directly, omega equal to 10 power 9 into pi, and epsilon is nothing but epsilon equal to, we have epsilon naught into epsilon r, epsilon naught into epsilon r. Therefore epsilon r is 49, therefore we need to substitute the 49 value here. So if you substitute 49, then if you simplify the expression, so finally we have sigma by 4, sigma by omega epsilon equal to, have the value 2.938, 2.938. So here this is neither very less than 1 or not very greater than 1. So it is a medium between the conductor and dielectric. It is a medium or in the midway of both conductor and dielectric material. So here we can find out the we need to find out the value of the magnetic field. So to find the magnetic field, here let us assume the intrinsic impedance. So here we have the intrinsic impedance formula, eta is equal to root of j omega mu by sigma plus j omega epsilon. Then if you substitute all these values, it is omega equal to, we have pi into 10 power 9, omega is nothing but pi into 10 power 9, and mu is equal to, we have mu naught into mu r, mu equal to, we have mu naught into mu r, where mu r is given 4, therefore mu is equal to, we need to substitute 4 into mu naught, mu equal to 4 into mu naught, therefore 4 into mu naught value is 4 pi into 10 power minus 7 by, so sigma is nothing but 4 plus again j into, again omega is nothing but pi into 49, and omega sigma epsilon is there, epsilon equal to, we have epsilon naught into epsilon r, where epsilon r is 49, therefore 49 into epsilon naught, 49 into epsilon naught, therefore it is 49 into epsilon naught values, it is 10 power minus 9 by 36 pi or 1 by 36 pi into 10 power 9. So if you simplify this one, if you simplify this expression, we have finally 240 pi into angle 45 degrees by root of 144 plus j into 49. So if you convert the same into again polar form, it is 240 pi into angle 45 degrees by, so here is a root of 15210 angle 9.39 degrees. So if you find out the value, total value in terms of polar form, It is 61.13 into angle 35.64 degrees. 64 degrees. Therefore, the magnetic field intensity is, so here we need to find the, we need to substitute the amplitude value. So here if you substitute the all is amplitude value, here it is. This one, it is 61.13. Amplitude is 61.13 into cos of 10 power 9 pi t, or omega t is actually given, minus beta x minus this angle 35.604 into ay. So it is a magnetic field intensity of a given problem. Next. So an elliptical polarized wave has an electric field of E is equal to sine of omega t minus beta z into ax plus 2 sine omega t minus beta z plus 75 degrees into ay volts per meter. Then find the power per unit area conveyed by the wave in free space. So here the electric field is a combination of both the x component and y component. So if you separate the x and y components, Ex equal to, we can express it as Ex equal to sine omega t minus beta z volts per meter, and Ey is equal to 2 sine omega t minus beta z plus 75 degrees volts per meter. So according to Poynting theorem, we have the power, average power or instantaneous power, and instantaneous power equal to, it is E cross H, where E is electric field intensity, H is a magnetic field intensity, and the average power P average equal to, we have half into E square by eta naught, half equal to E square by eta naught. So E square can be expressed as in terms of x and y coordinates. Therefore, E square is half into, it can be expressed as Ex square plus Ey square by eta naught, where the amplitude of Ex is 1 and the amplitude of Ey is 2. Therefore, so Ex square equal to 1 square plus Ey square equal to 2 square. Therefore, the average power P average equal to 1 by 2 into 1 plus 4 by the value of intrinsic impedance is 377 or 120 pi. Therefore, the average power equal to, here it is 0.00663 watts per meter square, or in terms of milliwatts, it is 6.63 milliwatts per meter square. So it is the average power of a given one. Next problem is the magnetic field H of the plane wave has a magnitude of 5 milliamps per meter in a medium defined by epsilon r equal to 4, mu r equal to 1 is given. So here we need to determine the average power flow, the maximum energy density in the plane. So we need to find out the maximum energy and we need to find out the average power. So here we have the ratio of electric field to magnetic field, E by H equal to eta naught, E by H equal to eta naught, which is nothing but the intrinsic impedance mu by epsilon. Therefore, which is mu is equal to, but mu is nothing but mu is equal to mu naught into mu is equal to mu naught into mu r. Mu r is given 1. Therefore, we can substitute mu is equal to mu naught, and where epsilon is nothing but epsilon equal to epsilon naught into epsilon r. Epsilon r is given as 4. Therefore, epsilon equal to 4 into epsilon naught. Therefore, in place of mu, we can substitute 4 pi into 10 power minus 7 by, in place of epsilon, here I am substituting 4 into epsilon naught value is 10 power minus 9 into 1 by 36. 4 ones, 4 nines. Then again, if you simplify the expression, it is 188.4 sigma. Sorry, ohms. 188.4 ohms. Then from this you can find out the electric field intensity. E by H equal to 188.4. Therefore, E is equal to 188.4 into H. The H is given as 5 meters per 5 milliamps per meter. 5 milliamps per meter. Therefore, the value is 188.4 into 5 into 10 power minus 3. For the electric field intensity is 942 millivolts per meter. Then we need to find out the average power flow. The average power flow is equal to, we have the formula P average equal to half into E square by eta naught. E square by eta naught. Therefore, it is half into E square is, it is 942 into 10 power minus 3 whole square by eta naught values 188.5 into 2. Directly here we can add the 2. Therefore, the average power is 2353.75 microwatts per meter square. Microwatts per meter square. This is the power. In this way, you can find out the electric field intensity and average power of a given problem. Then the maximum energy density. We can find out the maximum energy density. To find out the maximum energy density, we have energy density W is equal to, we have the formula epsilon E square, or we have maximum energy density equal to epsilon naught into epsilon R into E square. Therefore, already we have calculated the value. Epsilon naught values 8.854 into 10 power minus 12, and epsilon R is given as 4. Therefore, energy is equal to 4 into 8.854 into 10 power minus 12 into, and E square is 942 into 10 power minus 6. So here, if you simplify the same expression, the energy density is equal to 31.42 picojoules per meter cube. The energy density is 31.42 picojoules per meter cube. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.